Alright, so this is section 1.4, which is about radical equations, equations that are quadratic in form, which means that they can be changed into a quadratic and solved, and equations that are factorable. So we're going to start off with radical equations. Radical equations are any equation in which the variable is inside of a radical. It could be inside of a square root, inside of a cube root, inside of a fourth root, or any other higher root. Now, the steps that we follow to solve a radical equation: step 1, if necessary, we rearrange the terms so that one radical is isolated on one side of the equation. So you want to get a radical by itself on one side. Step 2, you're going to raise both sides to the nth power to eliminate the nth root. What that means is if you have a square root, you're going to square both sides. If you have a cube root, you're going to cube both sides. If you have a fourth root, then you're going to do a fourth power on both sides. Step 3, solve the resulting equation. Now, if this equation still has radicals, go back and repeat steps 1 and 2 again until you get rid of all the radicals. Okay. Once you've done that solve, figure out what x equals. The very last step is check all of the solutions in the original equation. Some solutions, when you plug them back in, will not work. And these solutions are called extraneous solutions. Okay? So let's look at some examples here. So example 1, we have solved the cube root of 2x minus 4 minus 2 equals 0. We have a radical right here, so this is a radical equation. But the radical is not isolated. There is this minus 2 behind it. So the first thing I'm going to do is I'm going to add 2 and move that over. And so I'll have the cube root of 2x minus 4 equals, when I add that over, I get 2. Right. Now I want to get rid of this cube root. To get rid of a cube root, we're going to raise both sides of the equation to the third power. Okay. Because what ends up happening is this third root cancels out with this third power, and so I just have 2x minus 4. Over here on this side, 2 to the third power is 8. It's 2 times 2 times 2. Okay, now we just need to solve this equation. There's no more radicals, so we just solve it like normal. We'll add the 4 across and say 2x equals 12. And then divide both sides by 2, and we will get x equals 6. Now we do want to check that answer, so we're going to go to our calculator to check it. I'll show you 2 different ways to do the cube root. There's kind of a longer way that I don't really like as much, and then there's a shorter way that requires you to remember something, but it makes it easier. The long way is you start by putting the number of the root. So this is a 3 root. Then you hit the math button, and you go down here and pick this here. Okay. Oops, I hit the wrong button. Sorry, my bad. What's this one down here? Okay, number 5. And then you open a parentheses, and then you type in whatever. Now, this works for any number. It could be a third root, it could be a fourth root, it could be a fifth root, it could be any kind of root. You might have noticed in the math menu there was a cube root in particular already there, which is number 4. You could use that if you wanted to as well. Okay? But that's one special, that's only cube roots. Okay? So I'm doing a cube root of, I'm going to have 2 times, the x we found was 6, minus 4. Then I close the parentheses because that closes my radical. Okay. And then I'm going to put the minus 2. And I hit enter. And it tells me it equals 0. So we know we got the right answer. Now, that's kind of the long way of doing it. Another way to do it is to understand that any time you have a cube root, it's the same thing as having a 1/3 power. Okay. These two things mean the same. This radical means the same thing as this power. So I could have just as easily done parentheses 2 times 6 minus 4, close parentheses, raised to the 1/3 power. And that would be the same thing as the cube root. And then I can do minus 2. And notice I still get 0. It still works out. Whichever way you prefer to do your cube roots to check your answer, that's up to you. Okay? But there is our answer for that one. All right. Example 2. Example 2 asks us to solve the square root of 2x minus 1 plus 2 equals x. This does have a radical in it, so it is a radical equation. The radical is not isolated, though. There is this plus 2 at the end. So I need to take the plus 2 and move it over to the other side. So I'll have square root 2x minus 1 equals, I move that 2 over, I will have x minus 2. Okay. So there we go. I've now isolated the radical. The next step is I want to get rid of this square root. To get rid of a square root, I square. And I have to do that on both sides. Now here on the left-hand side, the square root and the square cancel out, and you just have 2x minus 1. Over here on the right side, you have to be careful. Remember that x minus 2 squared really means x minus 2 times x minus 2. And so you have to actually FOIL it out. X times x, x squared, x times negative 2, negative 2x, negative 2 times x, also negative 2x, negative 2 times negative 2, positive 4. Combine like terms, you end up with x squared minus 4x plus 4 when you square this out. Alright, so then we want to solve this equation. Now, there's no more radicals. It is a quadratic equation now. So in order to solve it, we're going to move all of these terms over here. So I'm still going to have an x squared. When I move this 2x over, it's going to get subtracted over. So negative 4x minus 2x gives us negative 6x. And then with the 1, we're going to add it over. So 4 plus 1 gives me 5. Now that it's equal to 0, we can either try to factor it, or we can go to the quadratic formula, whichever is your preference. This one is pretty easy to factor, so I'm just going to factor it. In order to make up x squared, this has to be x and x, because that's the only way we can multiply and make that x squared. In order for the last number to be a 5, the only way we can do it is 1 times 5. I want the middle number to be a negative 6x, so both of these need to be a negative. So that way when I do x times negative 5, I get negative 5x, and negative 1 times x, and I get negative 1x. Together those make the negative 6x in the middle. Then we can take those factors, set them equal to 0, using our 0 product property. Add the 1 across, we get x equals 1. Add the 5 across, we get x equals 5. Okay. Now before we box these in, we do want to check them and make sure they work. Okay. So I'm going to go in over here, I'm going to do square root of 2 times 1 minus 1, close my square root, plus 2. I get 3. So that's what the left side is, 3. The right side is just x. Well, what's x supposed to be? X is supposed to be 1, so that answer did not work. So mark it off. Okay. All right, let's try our next choice, our next answer. So we're going to do square root of 2 times 5 minus 1, close my square root, plus 2. So I get 5. What am I supposed to have on this side? It's just x, which is 5. It works. So this answer is the only valid answer. This one right here is extraneous. Okay. So with extraneous, you do not box them in on a test. On something like My Math Lab, you would not type those in. You'd only type in this valid answer. Okay. All right. So there's that one. Example 3, we're moving into a little bit more complicated one. Okay. I have square root of 3x plus 1 minus square root of x plus 4 equals 1. Okay. I actually have two different radicals. Again, my first job is to isolate a radical. So I'm going to isolate this first one by taking the second one and moving it over. So I'll have square root 3x plus 1 equals 1 plus the square root of x plus 4. The square root becomes positive because we're adding it across. We're moving it across the addition. Okay. At that point, we've now isolated this radical. It's now isolated. So let's get rid of the radical. To get rid of a square root, we square both sides. Over here on the left side, the square root and the square can cancel, and so I just have 3x plus 1 equals. Over here, this is where you have to be careful again. This is 1 plus the square root of x plus 4 times 1 plus the square root of x plus 4. And we have to actually FOIL that out. So 1 times 1 is 1. 1 times the square root of x plus 4, that just gives us a square root of x plus 4. A square root of x plus 4 times 1 gives us another square root of x plus 4. And then lastly, a square root of x plus 4 times a square root of x plus 4, that gives us an x plus 4. Technically what happens, if you don't know this, I'll kind of write it up here. When you multiply square root of x plus 4 times square root of x plus 4, what technically happens is you have a square root of x plus 4 squared, because you're multiplying the stuff inside the radicals together. And then what happens is then the radical, the square root, and the square can cancel, and so you just get x plus 4. So if we combine like terms, we end up with x, which comes from this. We have a 1 and a 4, so that makes a positive 5. And then we have 2 of these square roots, so it's plus 2 square root of x plus 4. So there's where we're at after squaring. But here's our issue. We still have a radical. We still have a square root. So we need to isolate it. So that means I need to move all this stuff over. So I'm going to move the x over. 3x minus x is 2x. I'm going to move the 5 over. 1 minus 5 is negative 4. And that equals 2 square root of x plus 4. Okay. Then what I'm going to do is, between this 2 and this square root is multiplication. So I'm just going to divide both sides by 2. When I do that, 2x divided by 2 is x, minus 4 divided by 2 is 2, equals, over here the 2's can cancel, and I'll just have a square root of x plus 4. And so now the radical is isolated. Now that the radical is isolated, we can get rid of it by squaring both sides. Just square both sides. On this side, again, you're going to have to be careful. You need to actually do out x minus 2 times x minus 2. Actually FOIL it out. When you do FOIL it out, you'll get x squared minus 4x plus 4 equals. Over here, the square root and the square, this and this, can just cancel. And so I just have x plus 4. So now there are no more radicals. So all I've got to do is solve for x. It is a quadratic because of this x squared term. So I want to take these and move it over, so that way I have a 0 on the right-hand side here. So when I move the x over, so I'll still have the x squared, move the x over, negative 4x minus x is going to give me negative 5x. And then when I move the 4 over, 4 minus 4 is going to be 0. The 4's are going to cancel each other out. So this is where we're at. X squared minus 5x equals 0. Now, you could solve that equation with the quadratic formula, but it's actually really easy to factor. Since it's only 2 terms, you can just pull out the greatest common factor between them. The greatest common factor between these two is x. And when you pull it out of this, it'll leave behind an x. And when you pull it out of this, it'll leave behind the minus 5. So there's your 2 factors. Set each factor equal to 0. So you get x equals 0 and x minus 5 equals 0. That one's already solved for you. This one you just need to add the 5 across, so you get x equals 5. And so here's our 2 possible answers, 0 and 5. Again, though, you want to check them, make sure they actually work. So let's start with 0. I'm going to plug 0 into this equation. Square root 3 times 0 plus 1, close that square root, minus another square root of 0 plus 4, and I hit enter and I get negative 1. I'm supposed to get positive 1, so x equals 0 did not work. Let's try our other answer. Let's try 5. So square root 3 times 5 plus 1, close the first square root, minus second square root, we're going to have 5 plus 4, close that one, hit enter. And look, we got positive 1, that's what we're supposed to get. So x equals 5 is the only answer that works for this equation. So you might have noticed with these that we've kind of gone up in complexity. In part 1, when we got rid of the cube root and cube, we just got a number, really easy to solve. In example 2 here, when we got rid of the square root, we had to square this, which meant we had to do FOIL, and then we ended up with a quadratic, and then we had to factor, so it was a little bit harder. And then here, this is kind of the hardest of the ones that we did, because when we moved this over, we had to square to get rid of the square root, which involved FOILing, but then we still had a radical. So then we had to isolate again, square again, now we have a quadratic, then we have to factor and solve. So this is the kind of hardest that they can get in terms of types of radical equations. Okay? Alright, so that's one of the things we're looking at today is radical equations. The next thing we're going to look at is equations that are quadratic in form. Okay, what quadratic in form means is that they can be rewritten as a quadratic. And then once you rewrite them, you can solve them using the quadratic formula or using factoring, whatever. Okay. So here's two examples of these. We have x to the fourth minus 10x squared plus 9 equals 0. Okay. You could rewrite x to the fourth here. Wow, the pen went a little freaky there. You could rewrite x to the fourth there like this, as x squared getting squared. Because when you have exponents, if you have a power multiplied to a power, you add the two powers together. No, sorry. Power to powers multiply the power. Sorry, my bad. Power to the power, you multiply them together, so you have 2 times 2, which will give you the 4 there. Okay. Well, what that allows you to do is it allows you to do a substitution. I can say, hey, anytime I see x squared, let's just replace it with u. So right here I see an x squared, so I'm going to replace it with u. So I have u getting squared. Right here I see an x squared, so I'm going to replace it with a u. So this term becomes minus 10u plus 9 equals 0. Now, instead of being a fourth power function, now it's just a second power function. It's just a quadratic function, and we can solve it pretty easily. Here's a similar example. You have 5x to the 2/3 power plus 11x to the 1/3 power plus 2 equals 0. This term right here, x to the 2/3, could actually be written like this. X to the 1/3 getting squared. Because again, when you have a power raised to a power, you multiply the powers. And so 1/3 times 2 would make the 2/3 that you started with. But by writing it like this, I can do this substitution. I can say every time I see x to the 1/3 power, instead of writing that, I'm just going to write u. So I replace this with a u, so I have 5 times u getting squared. 5u squared. 11 times u. 11u. And then you still got the plus 2. And now you've changed it into a quadratic, and so you can solve it using any of the strategies we talked about in 1.2. So let's look at an example of this. Example 4 here asks us to solve x to the fourth minus 8x squared minus 9 equals 0. This x to the fourth could be rewritten as x squared getting squared. Minus 8x squared minus 9 equals 0. So it could be rewritten that way, so that way we have a power to a power, and these would multiply and make the original 4. Once you rewrite it like that, though, then what we can do, and I'm just going to change colors so you can see it, we can say, hey, assuming this lets me write, we can say, hey, let's let, sorry, I dropped my pen, let's let u let u equal within the parentheses here. So let's let u equal x squared. And so what that means is anytime I see an x squared, instead of writing it, I'm going to write a u. So over here, I have an x squared, so instead of writing that, I'm going to write a u. But what's happening to that u? Well, it's getting squared. Minus 8, here's another x squared. So instead of an x squared, I will write a u. Minus 9 equals 0.
And so now it's no longer a fourth power function. Now it's a second power function. It's a quadratic.
And then we can solve this with any of our methods. Now this one does factor really nicely. So I'm going to solve it with factoring. In order to make u squared, I need to have u times u. In order to make a 9, I could either have 1 times 9 or 3 times 3. Since I see an 8 in the middle, I'm going to go with 1 and 9. And in order for it to come out as a negative 8, this 9 would need to be a negative, and this 1 would need to be a positive. And then we can set those factors equal to 0. So u plus 1 equals 0. U minus 9 equals 0. Here you subtract the 1, you get u equals negative 1. Here you add the 9, so you get u equals positive 9. Now here's the problem. These are not my final answers,
because I did not originally start out with u's.
I started out, u is actually x squared. So here where I see a u, I need to write x squared. And here where I see a u, I need to write x squared. So actually I have two equations to solve. X squared equals negative 1 and x squared equals 9. Now luckily these are both very easy to solve by taking the square root. Okay. So you have x equals plus or minus the square root of negative 1. Over here you have x equals plus or minus the square root of 9. You can simplify both of those. This one's plus or minus. When you have square root of negative 1, that's just I. And then over here, plus or minus, when you do square root of 9, that's just 3. Okay. So we did our substitution, solved that equation with the substitution, and then substituted back in. Took our u, plugged it back in, and solved. Now you can check these answers, but you don't necessarily have to. It's not like the quadratic, or sorry, it's not like the radical ones where you had to check and see if your answers work. Here, these answers all will work because this was not a radical function. It was just a fourth power function. Okay. All right. Here we got another one. Two more of these kind of problems we're going to do. So I have x squared minus 1, all of that getting squared, plus x squared minus 1 minus 12 equals 0. So I can come over here and I can say, hey, let's let u equal, what's in this parentheses here? X, wow, sorry. Computer is acting up, of course. So let's let u equal x squared minus 1. So anytime I see x squared minus 1, I'm just going to substitute in. So this right here is on my x squared minus 1, so that's my u. And what's happening to that? It's getting squared. Plus, here I have another x squared minus 1, so that's another u. And then I have a minus 12 equals 0. Excuse me. At that point, you can now factor. Okay. You don't necessarily have to factor. You could use the quadratic formula if you so desired. Okay. In order to make the u squared, we would need to have u times u. In order to make the 12 at the end, you have a number of different options. You could do 1 times 12, 2 times 6, or 3 times 4. Now, since the middle number is a positive 1, then you would want things that are only 1 apart, which means you'd want 3 times 4. So we put a 3 here and a 4 here. To make it come out as a positive 1, the 4 would have to be positive and the 3 would have to be negative. So that way they add up to positive 1. Then we could take those factors and set them equal to 0 and solve. So I get u equals 3, u equals -4. But again, here's our problem. We did not start out with u's. We started out u was actually x squared minus 1. So I'm going to rewrite that. That's x squared minus 1 equals 3, and x squared minus 1 equals -4. And then we just need to solve those. Add the 1 across, x squared equals 4. Here, add the 1 across, x squared equals -4 plus 1, which is -3. Then we can get rid of the square by taking a square root. So x equals plus or minus the square root of 4. Over here, x equals plus or minus the square root of -3. And then you want to simplify those. So you get plus or minus, the square root of 4 is just 2. And then over here, x equals, the only thing we can do is we can get rid of the minus inside the radical. So we'll have plus or minus I square root of 3. That's really about all we can do with that one. Okay. And so there's our 4 different answers for this equation that is quadratic in form. That's it. Alright, let's look at one more example of this. Example 6 asks us to solve x plus 2 square root of x minus 3 equals 0. Now, this one may or may not look like it's quadratic in form, but it actually is. Okay. If we let the u equal square root of x, if I can actually write a square root of x. Okay. So if I let the u equal square root of x, what would happen if I take that u, I'm just going to rewrite it really quick. If I take that u and I square both sides. Okay. Well, here on the left side, u getting squared would be u squared. Here on the right-hand side, the square root and the square would just cancel out, and you would just have x. And so that means that if we let u equal the square root of x, anytime we see x by itself, that means we have just u squared. And so what we're going to do is we're just going to take these and substitute them in here. This is just an x, so instead of writing x, I'll write u squared. Plus 2, this square root of x, that's just my u, so 2u. And then minus 3 equals 0. And so there we go. Now we've changed it from a radical equation into a quadratic equation, which is a little bit easier to solve. Okay. So then we want to factor. In order to make u squared, we would have to have u times u. In order to make 3 at the end, we're going to have 1 times 3. For it to be a plus 2 in the middle, the 3 is going to have to be a positive, and the 1 is going to have to be a negative in order to make it be a positive 2. So then we have u minus 1 equals 0, u plus 3 equals 0. Move the 1 over, u equals 1. Move this 3 over, u equals -3. But again, we didn't start with u's, we started with square root of x. So what we really have is square root of x equals 1, and square root of x equals -3. To get rid of a square root, you square both sides. I'm going to do that over here too. So I get x equals 1 squared, which is 1. Over here I get x equals -3 squared is 9. Now before I box these in, I do need to check them this time, because there was a radical in the original equation. So I do need to check, make sure they work. So here's my calculator. 1 plus 2 square root of 1 minus 3. Yep, x equals 1 works. It does give us 0. Okay. Let's check our other one. We're going to check 9. So 9 plus 2 square root of 9, and then minus 3. Ooh, that one gave us 12. Okay. 12 does not work. 12 is not 0. So that answer there is extraneous. So mark it off. So only 1 is a valid answer for this equation.
Okay. Alright, so
those are equations that are quadratic in form. The very last thing we're going to do is we're just going to look at some other equations that we can solve by factoring. Now with these, the same principle works. The zero product principle still holds true. You want it to equal 0 before you factor and do any of that stuff. Okay. So, look at this first equation. We got x to the 4th equals 4x squared. We want to make it equal 0, so we'll move the 4x squared over and say x to the 4th minus 4x squared equals 0. Now that it equals 0, we can factor. Because this is just a two-term equation, we can factor by looking for the greatest common factor. In common between both of these is an x squared. When I pull an x squared out of this x to the 4th, it leaves behind an x squared. When I pull an x squared out of this negative 4x squared, it just leaves behind a negative 4. And so there it is factored. Then we're going to set our factors equal to 0. So we'll have x squared equals 0, x squared minus 4 equals 0. For this one, you could just solve by taking the square root on both sides. The square root and square will cancel. You'll get x equals, square root of 0 is 0. Oops. Don't know why the box went that way, but apparently that's where it wanted to go. On this other one, the very first thing we would need to do is add the 4 across. So we'd have x squared equals 4. And then we could solve by doing our square root. Please remember to do plus or minus. And then square root of 4 is 2. So there we go. This equation actually has 3 different solutions: 0, positive 2, and negative 2. Now, you don't have to check these if you don't want to. You can check them. You can plug them back in and see if it works. But you don't have to like you do with radical equations. All right, last example for this section. It asks us to solve the equation x to the 3rd minus x squared minus 4x plus 4 equals 0. Now, the nice thing is it already equals 0, so I don't have to move anything. The not-so-nice thing is this is a 4-term equation. 1 term, 2 term, 3 term, 4 term. When you have a 4-term equation, the only thing you can do is what is called factor by grouping. And what that means is we're going to group these elements. And then we're going to factor within these groups. So let's look at this first group. We have x to the 3rd minus x squared. Is there anything in common between both of those that I can factor out? Well, yeah, in between both of them, I can factor out an x squared. When I pull an x squared out of this first term, it leaves behind a x. When I pull an x squared out of this negative x squared, it leaves behind a negative 1. So that's what I can do with the first group. Okay. Then I look at the second group. Is there anything in common between the second group? Okay. Well, I can actually pull out a negative 4. When I pull a negative 4 out of this first term, I leave the x behind. When I pull a negative 4 out of this positive 4, I leave a negative 1 behind. Okay. And that still equals 0. That's still there. Now that we've looked at the two groups and we've factored within the groups, now what we're going to do is we're going to factor between the two groups. Do you see something in common between this first group and this second group? Well, yeah, if you look, what's in the parentheses is in common between the two groups. So I'm going to factor out that common thing. I'm going to factor out that x minus 1. When I pull that x minus 1 out of this first group, all that gets left behind is the x squared. When I pull the x minus 1 out of the second group, all that's left behind is the minus 4. And there we go. Now it's factored. Now that it's factored, we can set the factors equal to 0, and we can solve. For this one, we would just add the 1 across, and we would get x equals 1. On this one, we would add the 4 across, and so we would have x squared equals 4. And then to get rid of the square, we would do a square root on both sides. And so we would get x equals plus or minus, because we did a square root, and then the square root of 4 is 2. So there we go. There are our 3 answers for this original equation. 1, positive 2, and negative 2. Again, factor by grouping works anytime you have 4 terms. So you can split it into a group of 2 and a group of 2. As always, if you have any questions about anything on the homework or anything else, just send me an email. I'll try and get back to you as quick as possible.